Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm a CCNA and CCNP certified instructor. Today we'll cover Chapter 11. It's a network. This is part of CCNA Semester 1, Introduction to Network. This chapter is divided in 4 sections. Section 11.1, Create and Grow. In this section we'll identify the devices and protocol used in a small network, explain how a small network serves as a basis of large networks. Then we move to section 11.2, keeping the network safe. Describe the need for basic security measures on a network devices. Configure network devices with device hardening features to mitigate security threats. Then we move on to section 11.3, basic network performance. Use the output of ping and tracer command to establish relative network performance. Use basic show and commands to verify the configuration and status of the device interface. And use the basic host and iOS commands to acquire information about the devices in a network. Explain the file system on the router and switches. Then we move on to section 11.4, managing iOS configuration file. Apply the commands to backup and restore iOS configuration file. Okay, let's start. 11.1, create and grow. Okay, we start with section 11.1, create and grow. Now, small network topologies. The majority of businesses are small businesses. It is not surprising then that the majority of networks are small networks. The number and type of devices on a network are reduced compared to that of larger networks. The network topologies for a small network typically involves a single router and one or more switches. Small networks might also have a wireless access point. Possibly this is built into the router, and an IP phone. As for the connection to the internet, normally a small network has a single connection provided by DSL, cable, or an Ethernet connection. Managing a small network requires many of the same skills as those required to manage a large network. The majority of work is focused on the maintenance and troubleshooting of existing equipment, as well as securing devices and information on the network. Device selection for a small network. When selecting the type of intermediate devices, there are a number of factors that need to be considered. First one is cost. Cost is typically one of the most important factors when selecting equipment for a small business network. Speed and types of ports, interfaces. Choosing the number and type of ports on a router or switch is a critical decision. Questions to be asked include: do we order just enough ports for today's needs? Or do we consider growth requirements? Do we require a mixture of UTP speeds? And do we require both UTP and fiber ports? Then we have expandability. Network devices come in both fixed and modular physical configuration. Fixed configuration have a specific number and type of ports or interfaces. Modular devices have expansion slots that provide the flexibility to add new modules as requirements evolve. Operating system, features and services. Depending on the version of the operating system, a network device can support certain features and services, like security, quality of service, voice over IP, layer 3 switching, NAT, DHCP, and so on. IP addressing for a small network. IP addressing scheme should be planned, documented, and maintained based on the type of devices receiving the addresses. Example of devices that will be part of the IP design is end devices for users, servers and peripherals, hosts that are accessible from the internet, and intermediary devices. Planned IP schemes will help the administrator to track devices and troubleshoot, control access to resources. Redundancy in a small network. Another important part of the network design is reliability. Even small businesses often rely on the network heavily for business operation. In order to maintain a high degree of reliability, redundancy is required in the network design. Redundancy helps to eliminate single point of failure. So redundancy can be accomplished by installing duplicate equipment, but it can also be accomplished by supplying duplicate network links for critical areas. Design consideration for a small network. Users expect immediate access to their emails and to the files that they are sharing or updating. To help ensure this availability, the network designer should take the following steps. Step 9. Secure files and emails and mail servers in a centralized location. Step 2. Protect the location from unauthorized access by implementing physical and logical security measures. Step 3. Create redundancy in the server farm that ensures if one device fails, files are not lost. And step 4, configure redundant paths to the servers. In addition, modern networks often use some form of voice or video over IP for communication with customers and business partners. The network administrator should consider the various types of traffic and their treatment in the network design. Common protocols in a small network: we have a network application. Applications are the software program used to communicate over the network. Some end-user applications are network aware, meaning that they implement application layer protocol and are able to communicate directly with a lower layer of the protocol stack, like transport layer and network layer. Email clients and web browsers are examples of these type of applications. Application layer services are the programs where need the assistance of application layer services to use the network resources, like file transfer or network print spooling. Each application or network services uses a protocol which defines the standards and data formats to be used. Without protocols, the data network would not have common way to format and direct the data. Real-time application for a small network. Real-time application require planning and dedicated services to ensure priority delivery of voice and video traffic. Infrastructure needs to be evaluated to ensure it will support proposed real-time application. Voice over IP is implemented in organizations that still use traditional telephones. IP telephony, the IP phones itself perform voice to IP conversion. And real-time video protocols, they use real-time transport protocol, RTP, and real-time transport control protocol, RTCP. Scaling a small network. Important consideration when growing to a larger network is documentation, physical and logical topologies. Device inventory, list of devices that use or comprise the network. Budget, itemized IT expenses item, includes the amounts of money allocated to equipment purchased for the fiscal year. Traffic analysis, protocol application and services and their respective traffic requirements should be documented. Protocol analysis of a small network. Support and growing a small network requires being familiar with the protocols and network application running over the network. Protocol analyzers enable a network professional to quickly compile statistics information about the traffic flows on the network. When trying to determine how to manage network traffic, especially as the network grows, it is important to understand the type of traffic that is crossing the network as well as the current traffic flow. Capture traffic during peak utilization time to get a good representation of the different traffic types, and then perform the capture on the different network segments because some traffic will be local to a particular segment. Okay, on this demonstration I will demonstrate what protocol are running on our network. For this demonstration we're going to use GNS3 together with VMware. So I'm going to actually create a whole network from the scratch within GNS3 and in VMware. So if you already know how to do that, you can skip it. Okay, so what I'm going to do now is I'm going to start a GNS3. Okay, I'm going to actually start a brand new, I'm going to create a new network. So, okay, I'll say okay. No, I don't want to overwrite. Let's say today's date, or let's just say chapter 11. Okay. And for this, I'm going to use one router. So 15 router, one switch, Ethernet switch, and I'm going to use cloud for PCs. So I'm going to use one cloud here and take another cloud here. Those are going to be my PCs. So if I right click the cloud one and change the symbol, so I just want to put as a PC the symbol, computer, okay, and change the name, change the host name. This is going to be a PC A, okay. And we're going to configure this. I'm going to put VMnet 12, I think it is. Yes, VMnet 12, add that and okay. And I'm going to do the same for this cloud here, change the symbol. So I'm just going to put computer name. I'm going to change the name to PCB and put the network to be the VMnet 12 as well. Add that. Okay. Right. Now this one is going to cause me a problem. So I'm gonna put this on a different VMnet. So VMnet, put this, delete this, and it's going to cause a loop. So I'm going to put VMnet 11. So add that. Okay. Now I'm going to connect those PCs and a router. So router fast Ethernet 00 to the switch. PC VMnet 12 to the switch. And then the PCB to the switch as well. Okay. Now I'm going to open the VMware. Open my VMware. And I got PCA here and PCB. Now PCA is on the VMnet 12 as well. They're all in VMnet 12. And PCB as well in the VMnet 12. Right. The reason why I got it here is just for visual representation. This PC doesn't really, it's just on the VM in VMware. Okay, so what I'm going to do here is I'm going to type IP addresses for this router in FA0000. The IP address is going to be 192.168.12.1/24, and they're going to have the PCA is going to have the IP address 192.168.12.100, and PCB is going to have the IP address 192.168.12.200. Right. This demonstration is about seeing what kind of protocols are running in our network. So if I go back to VMware, so PCA, I'll just turn that PC on, and the PCB as well, I'm going to turn that machine on as well. Right, I'm going to turn on the router as well. So right click the router and say start, and then open secure CRT and connect to the GNS1. So connect there. Okay, let me go back to the PCs to see if they working. Yep, we got the PC there, PCA. Let's start it, PCB. Okay, so what I can do, I can go to PCA and give an IP address. So click start, control panel, network and internet, network and sharing, local area connection 2, and go to properties of that. Select TCP IP and properties of that. And the IP address for PCA was 192.168.12.100. That's the subnet mask /24, and the gateway 192.168.12.1. That's my gateway, even though really don't need it. There's no any other network to go out. And do the same for PCB. So I can just do it here. I can right click this and say open network and sharing. Local area connection, properties of that, and it was 192.168.12.200, and then 192.168.12.1, the IP address of the router. Okay, close that, and we can close that as well. Okay, so you showed how you saw it how to open through control panel, the network connection, through if I right click there, or another shortcut. So for you for future learning, ncpa.cpl, that will open your network connection, and then you can go right click and so on. That's a shortcut as well if you want to use. Okay, so if I go to the router and start configuring the IP address, so config t,
interface FA00, given IP address was 192.168.12.1.0. The subnet mask and no shutdown. Okay, so if I go to my PCs again and try if I ping it, so I open the PC A, for example, and open the command prompt cmd and ping that. So ping 192.168.12.1, and yeah, I have a reply. And I do the same from PCB. So open the command prompt cmd ping 192.168.12.1. Yep, I have a reply as well for that. Excellent. So now what I'm going to do is I'm going to open the command prompt. I'm going to open the Wireshark and just see what protocols are running there. I'm going to enable HTTP as well. So we have some kind of. So I'm going to do IP HTTP server, right? And I'm going to create a local database. User name, say student1, password CCNA, and I'm going to do password CCNA1, let's say that, and let's do the same for student2 and password CCNA2. Yeah, excellent. Okay, so I'll go to open GNS, right click on the link here and select start capture. Do I want to capture for router 1? Yep. Ethernet interface, fast Ethernet. Click OK. Then we're going to see the Wireshark protocol analyzer is going to start. Let me just fit it in the screen so we can see it nicely. There we go. There's our protocol analyzer. It started right there. Okay, so we have some messages coming. Loop, some UDP, quite a lot of UDP. DHCP v6, so solicited messages, UDP messages. They come in from 120.1. That's probably from VMware or something. There's no 120. Our protocol is 192.168.12. It is. Okay, so let's just start some ping and see. So if I say ping 192.168.12.1, so I should be seeing some pings. You see, I got some request from 12.100, and reply again coming back from 192.168.12.1. Okay, and then another reply. I sent 5 pings. Yeah, so that's why you see 5 of echo. ARP, remember ARP was address resolution protocol, so it's asking like my PC, the PCA is sending a message, who has IP address 192.168.12.1, tell 192.168.12.100, so that's PCA, so who's got that IP address, and then the address from 192.168.12.1 is coming and it's saying, okay, here's my address and here's my MAC address for that. So it's trying to resolve an IP address to MAC address. Then we have some loop message that lays out like a ping for layer 2 kind of. So if I open a web browser, for example, say I go to PCA, open the PCA again. No, I don't want to close it. Okay, PCB is fine. So go to the web browser and type IP address there. You see already it's gonna, because he's asking like a LLMNL. This is the link local multicast name resolution. This is for IPv6 and IPv4, like a DNS is a query messages that's coming. So he's asking, he's trying to locate the Microsoft.com. Okay, so if I put the IP address 192.168.12.1, for example, that's the IP address of the router. So it goes right away. We get in some messages there. There's some TCP messages. They come in like a 3-way handshake. Synchronization coming from the PC. The synchronization coming from the router. That's from the PC 200 there to 1, and that's from the router from 12.1 to 12.200. Acknowledgement and another synchronization, and then the finish of the synchronization messages, and then get the HTTP server. is being unauthorized. NBNS is a protocol, for example, for query messages as well. We got some CDP protocol there, a message from the CDP, and so on. So now, like this, you will find out all different kind of protocols that's running on your network. Any of these that you see, you can open them, you can look at them. For example, say that we open this ICMP message, right? Let me bring it on the screen. You can, for example, investigate who's sending it, what is the message about, and so on. For example, Ethernet 2, which is source, is this MAC address, and destination is this to this MAC address. Then we have a layer 3, the version, the header, layer 3 header, the source 192.168.12.100, the destination 192.168.12.1, and time to live, what protocol is inside this ICMP 1, and then you can look at internet control messages, or ICMP, which is ping. Type 8 says echo, is request, and there's 32 bytes in it, right? So if we look at the reply, for example, very quickly, let me bring that on the network. Let me just try and I'm trying to maximize this. Okay, it's not working. Okay, here we go. ICMP type 0, for example, is a reply. So type 8 was request, type 0 is reply, and checksum is correct. Here we see it. Again, now it's coming from the router and it's going to a destination, which is PCA. Okay, that was a demonstration about observing protocols that are running in our network.